Hello coders, welcome to my channel. I am Aniket and today we will discuss problem from GFG, that is exit point in a matrix. Let's read the problem. Given a matrix of size n cross m consisting zeros and ones, you start at the top left cell 0, cell 0, 0 and initially move in the left to right direction. So a 2D matrix is given to you which is containing some rows and some columns, and you are initially at 0th row and 0th column, and your initial direction is right. I hope you got this. While traversing the matrix, follow this rule. If the current cell contains 0, continue moving in the same direction. And if the current cell is 1, change your direction to the right, clockwise turn, and update the cell value to 0. So this is very simple. If the current cell containing 0, then you don't do anything, don't change your previous direction, keep your previous directions as it is. But if you found a 1, then you have to change your direction. If you found 1, then you have to change your direction. Let's make a table which is denoting that which direction will result to which direction after if you found a 1. So if you are moving upward and a 1 come, then you should change your direction to right. If you are previously moving downward and a 1 come, then you should change your direction to left. If you if you moving left previously and a 1 come, then you should change your direction to upward. And if you moving right and a 1 come, then you should change your direction to downward. It is a table which is denoting that if the previous move is upward, then if the 1 comes, then you should change your direction to right. And if the previous move is downward, then you should change your direction to left. Similarly, this table is filled. Now let's read the remaining part. You continue this process until you move outside the boundary of the matrix. So you will continue this process until you will get out of the matrix. Your task is to determine the coordinates, row and column index of the cell from which you exit the matrix. So what is the objective of our question? We want to find the exit point. So what are the parameters that are essential to find this exit point? The various parameters are essential parameters. There are various essential parameters. First parameter is we should consider our previous movement, because it will help us to find the next movement. That's why previous movement is very important. And we should store our previous cell also, so that we can easily predict our next cell. We should consider our grid also, because it is very obvious, without grid how can you traverse. So grid is also very important. And we should consider our current position also, such that if our current position is out of the matrix, so we can simply return our previous cell. If our current position is out of the matrix, so we can simply return our previous position as answer. I hope you got this. Now let's jump to the code. But before that, please hit the like and subscribe button so that it will motivate me to make such kind of intuitive video for you. I will consistently make such kind of videos. So please ensure that you hit the like and subscribe button. Now let's discuss the code. Here's my simple Java code for this problem. So in this problem, the input is matrix which is of 0, 1, which is storing 0 or 1, and I will initialize it globally so that there is a limited parameters in the main function, that is move function. And I will initialize my n and m, which is denoting the rows and columns of the matrix, and I will initialize it in this function. And simply uh, I will initialize this parameters. First, the question specifies that our initial direction of movement is right. That's why I will take r as our initial movement, and our previous position is nothing, so that's why I will initialize it -1. -1 denotes that there is no previous position. And in the question it states that our current position is 0 comma 0. That's why our current position p and q are initialized to 0 0. Let's jump to the recurrence. And if our current position is out of bound of the matrix, then we simply return our previous position. This will simply signifies that current position is out of bound. So in that case you have to return your previous position. Return previous position. And if the matrix p comma q, that is current position, contain a 1, then you have to make this 0, because the question states that you have to change this 1 to 0. And after that, if it is u, then you go to right. If it is d, then you go to left. If it is right, then you go to down. If it is left, then you go to up, just like in this table as I discussed. This is the basic table, very important table for making this recurrence. So if the matrix p comma q is equal to 1, then you go to right, and for right you consider this current position now, and your previous position will become p comma q, and your current position will become p comma q plus 1. Similarly here also, if the current character is down, then you have to consider left movement, and for left movement you have to -1 from your column, and row will be same as it is. And I hope you understand this, how this movement will done. And if the matrix of p comma q is equal to 0, then you simply retain your direction. Don't change your direction. You will remain in your direction as before, and you will update your previous position and current position according to this, because matrix of p comma q is equal to 0, so your previous position is same as your current direction, previous direction is same as current direction, previous direction is same as current direction, because matrix of p comma q is equal to 0. And simply if you reach at any point that you find you into the out of the matrix, then you simply return your previous position as answer. I hope you understand my code and the intuition behind this code, how this table is made. And this table is very important to make such kind of recurrence. Please hit the like and subscribe button so that you can't miss any POTT discussions in future. Thank you for watching my video.